Good morning. Okay, so today we're going to talk about Newton's third law. So let's talk about force. If you were to look up force in the dictionary or probably online on Webster's dictionary, you would see that force is defined as the power of energy, strength, the force of a gale, power exerted on any resisting person or thing. Well, obviously, this definition was not made by anyone who knows physics. It's completely wrong in the physics world, but probably in the grammar world, it's okay. If you were to ask Yoda, he would say, use the Force, Luke. But we are not in Star Wars, unfortunately. So, force. For us, the definition of force is a push or pull. If you want to pull something, you can see how hard you're pulling it by using the spring scale. And if you want to push something, use the bathroom scale. The direction of push, you use your gut. So, two cars collide. So, let's say this little car collides with this big truck. Which one feels the greater force? Take a moment and just think about it. Commit yourself to an answer. If they were to have force sensors on their bumpers when they hit, you would see that the force of one would actually counteract exactly with the force of the other one, even though one's a little car and one's a big truck. But when they hit, we know that the little car gets more damage. So even though they feel the same force, the little car has more damage or is likely to have more damage. Why is that? Well, it's because the little car is made out of material that is crumpled easier than the truck. It's for various reasons. We'll talk about this at a later date when we talk about momentum. So Newton's third law. Newton's third law is if a red object pushes on a blue object, the blue object always pushes back with a force that is equal in strength and opposite in direction. So let's look at any red and blue object, in this case a car and a truck, but it could be anything. If we were to look at part of a free body diagram for each object, we see that the blue truck is pushing, so it's a normal force on the red car, and the red car is pushing, also a normal force on the blue car. They are equal in length and opposite in direction. Okay, so let's look at the space shuttle. Let's figure out some applications in Newton's third law. So we have this space shuttle, and what is making the space shuttle rise off the ground into space? Think about it for a second. Commit yourself to an answer, and then we'll talk about it. Well, okay. So a lot of times students say that the space shuttle is pushing off the ground. Well, the ground is down here, and the space shuttle is no longer touching the ground. So the ground cannot have a non-contact force on the space shuttle. It has to have a contact force on the space shuttle. So what is pushing it? Well, let's see. We know that there's a bunch of gas coming out. And this space shuttle pushes the gas out so fast that it actually lights on fire. It's probably lit on fire before it comes out. But all these little molecules are being pushed out of the space shuttle. So the space shuttle is pushing the molecules down. Well, Newton's third law says that for every force, there's an equal and opposite force. So for every force that the space shuttle pushes that little particle, the little particle pushes back with an equal force in the opposite direction. So all those little tiny forces add up and push the space shuttle up. Oops, what thing's pushing the rocket? Is this a contact or non-contact force? It's actually a contact force. So spaceship. If we want to go right, so if we want to go right, then we'll spew things out this way, and the little gas pebbles will push our spaceship that way. Okay. You are stuck in the middle of a frozen lake holding a large bag of gold. The surface is perfectly frictionless. How do you get off the ice? So you're on this huge lake holding a bag of gold on dress-up day, apparently. And it's frictionless. So because it's frictionless, you cannot walk off the ice. You'll just look like a chicken standing in place because there's no friction between your foot and the ground to propel you forward. So, what must you do? Think about it, pause the video, and then come back for the answer. Okay, so here is our here's our lake, here's our guy holding the bag of gold. Oops. Oh, where's that guy? There we go. If he throws the gold one way and he pushes the bag one way, he will propel the other way off the ice. Okay, so Gary has a major problem. After studying Newton's third law in his physics class, he has convinced himself of its validity. Unfortunately, he has convinced himself while standing in a closed room with a single door. He reasons to himself, if I push the door to go out, Newton's third law tells me that the door is going to push back with an equal force. That is a force going to and that force is going to cancel the force I push with. Even if I push as hard as I can, the door is going to push back just as hard. Oh no, I'm stuck in this room. Why did I ever take physics? All right, not to fear, Gary. What is the problem with Gary's reasoning? Why don't you pause the video, think about it, and then come back. Okay, so welcome back. Gary is thinking if he pushes the door, so let's have a door. Let's use this as a door. So he pushes the door. So there's two objects. There's Gary and the door. So if he pushes the door, yes, of course the door pushes back, but the door is going to be pushing back on Gary. So these forces don't cancel out because they're two objects interacting with each other. So the forces don't act on the same object, they act on two different objects. So Gary is able to leave because the force that Gary pushes on the door is not canceled out by the door pushing on Gary. It would only be canceled out if both forces were acting on the door. Okay, so one last problem. A bug splats on your windshield of your car. You're going very, very fast, naughty person, 100 miles per hour. Which feels the greater force, the car or the bug? Take a moment, pause the video, think about it, and come back. Welcome back. All right, so a bug splats on the windshield of a car moving 100 miles per hour. Which feels the greater force? So, they feel the same force. Which has the worst day? The bug, of course. The bug dies. Now, why does the bug die and get splattered while the windshield nothing really happens? It's the same idea as the small car and the big car. The bug is more fragile than your windshield, so it's much easier to splatter the bug than to hurt your windshield. Of course, if you hit a large enough bug, that could crack your windshield. All right, you have a wonderful day, and I will talk to you all later. Bye-bye.